Hey everyone, in this lesson we are going to be exploring the command pattern inside of Unity. Now the command pattern is great and is very good for not just coding, performance and flexibility, but overall design of your games as well. So the command pattern at its core basically allows actions to be represented as objects. Now, this basically means we can stack up commands and execute them when needs be. Or in the case of what we're going to be creating here, we have the ability to undo commands to basically play the actions or play the inputs the player has just executed in reverse and then redo them. Okay. Now, this is great for RTS games where you might want to stack up multiple commands for a player to then execute. Turn-based games as well. Anything that requires a number of commands, a number of actions to be performed in a certain order, this is a great way of doing that. And you could even expand upon this system in order to create replay systems for your games, to create playbacks, that sort of thing. So let's look at how we can implement the command pattern inside of Unity. So what I've got here is a little example scene. So basically in the scene, I have a cube in the middle, which I've named player. And this player we are going to be moving around with the arrow keys, okay? And then down here we have an undo and a redo button. Now these two buttons are going to be what we can do to basically replay our command. So we'll move the player around with the arrow keys, and then we'll be able to click undo to basically undo that input, and then we can see the player basically then going in reverse, and then redo will allow us to then play that back. And this is just to have a look at how we can stack commands, undo them, and redo them when we wish. Now, let's get down to the scripts. So down here, I have 4 different scripts. I have command executor, iCommand, move command, and player movement. Now we're going to go through and fill each of these in. But first of all, I'm going to select our player right here, and I'm going to attach the player movement script. Now you can go ahead and create these 4 scripts right now. Attach player movement to the player. And then I'm going to create a new empty here, and I'm just going to call this one our command executor. And I am going to attach to this one the command executor script like so. Now, let's begin by creating the base class or the base interface for command. So I'm going to open up the iCommand script right here. Now, an iCommand is going to be an interface, and it is going to basically lay out 2 functions, execute and undo. So let's go ahead and create that right now. So delete the content here. We're going to remove monobehavior and replace class with interface. Now, iCommand, we are going to have 2 things. We're going to have a void execute and a void undo. Now, a command is basically going to be, well, anything. In our case, we are going to have a movement command, which is going to, when executed, move the player along a certain direction, okay? You can have other commands as well. You might have a jump command, you might have a change color command, you might have an on and off command. Anything in your game that you want to happen or have a state change, you can define as a command. That is why we are setting this up as an interface, so we can easily attach this to all sorts of different command types later on. Now, the execute function is going to be called when we want that command to play out. So for example, if this command is for the player to move up, well, execute would move the player up. And then when we call the undo function, that would basically reverse the command, okay? So that would then move the player down, essentially. Or if you have a command to turn on a light bulb, execute would turn it on, and undo would turn it off, okay? Or revert back to its previous state. Now, what we're going to do next is move over to our move command script. Now, move command is going to be where we actually define the meat for the movement command for the player, okay? Now, this here, we're going to remove start and update, and we are going to replace the monobehavior with iCommand. Now, this script is not going to be attached to a game object, so that is why we are not using monobehavior. Rather, we are creating a new class of type iCommand. You'll see we have the red line, and that is of course because we need the execute and undo functions. Now, to easily do this, I'm going to click on iCommand here, hold down Alt, press enter, and then press enter again. And that is then going to create the 2 functions for us right here, execute and undo. Inside of here, what we're then going to do is we are going to need two properties for this command, okay? Because this command is going to need to know two things. First of all, what it is going to move, and second of all, the direction and vector it's going to be moving in. So for this, we're going to create a private player movement. Now this player movement is once again that script we created, and this here we are just going to call player movement. And then we'll create another one here. This is going to be a vector 3 for the movement. So in order for this move command to exist and run, we need to know these two things: what we are moving, and then the vector we are applying to its position. Now, since this is not going to be a mono behavior, it's not going to be a component we attach, we are going to define a constructor for this class, because when we create a new class, we want to provide it with this information. So to make the constructor, we're just going to go public move command, and we're going to be sending over two parameters. These are going to be the player movement, so player movement like so, as well as a vector 3 for the movement. Now, inside of here, we basically want to just set these variables. Now, to set a variable that has the exact same name as a parameter, we can just go this.player movement, which is referring to our variable player movement up here, and then we can just go equals player movement, okay? So here we are setting the variable player movement, this meaning this instance of the class, and then we are setting this to be the parameter, which refers to here. We can do the same thing for movement, this.movement equals movement, and there we go. Now down here in the execute and undo functions, we can't actually fill those out just yet, because we first of all need to define our player movement function, or our player movement script. So over inside player movement, what I'm going to do is I'm going to delete all of this, and I'm going to create a public void move function, okay? Now move is going to take in a vector 3 for the movement, and what we're going to do here is simply apply this to our position. So we can go transform.translate, and this is then going to take in the movement, okay? Now translate is a function which basically just applies a vector to our current position. Now back inside of move command, what we can do is go down to execute. So this is where we want to execute the move command, and basically we are just going to go player movement dot move, and we'll send over the movement variable. Now undo is basically going to do the opposite of that. Now to do this, it's fairly simple. We're just going to go player movement dot move, and we are going to be sending over negative movement, okay? So if this vector here is up, well, when we undo it, it's going to be down. If it is left, it's going to be right. If it's forward, it's going to be back. Okay, so we're basically negating that movement vector right there. So we have our I command, which is the interface for execute and undo. We have our move command, which is basically creating that command. It's taking in what we are moving as well as the vector. And then we are filling in the execute and undo functions to correctly execute that command and then undo that command when needed. Now, how can we actually go ahead and get this working? Because right now we've created these scripts, but they don't really do anything. Well, that is where the command executor script comes into play. Now, inside of command executor, we are going to delete start and update here, and we are going to create 3 new variables. The first one is going to be a serialized field because we want to access this in the inspector, and this is simply going to be our player movement, a reference to our player movement. The next 2 variables are going to be stacks. Now for this, we are going to be using the system.collections.generic library. And then down here, I'm going to go private stack of I command. And this is going to be called undo stack of new stack I command. Now, whenever we are going to execute a new command, we are going to add it to this stack here. Now, a stack is very similar to a list or a queue if you've used those before. Basically, a stack is first in, first out. So you can think of it sort of as a Pringles can or something like that. When you put something in, they sort of stack on top of one another, and then when you want to take something out, you have to take the top thing out. So basically, if we put a command in, we have to take that command out first. And this is basically how we are going to do our undo cache here. And we're going to do the exact same thing. We're going to create another one, another stack of I commands called redo stack. equals new stack of I commands. So when we are undoing stuff, we have we're going sort of back in time, you can think. So then we have the commands from our current position to our most recent that we are then stacking up here. And when we redo, we'll go through those. Now, in the next lesson, we are going to go ahead and fill out this script. We'll also look a bit more into the stack here and exactly how it works. So I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be continuing on with our command executor here. So what we're going to do now is we are going to create some functions. So first of all, we are going to have the update function. This is where we are going to be detecting our inputs. We are then going to have another function called void execute command. Now this is going to take in an I command variable here, or parameter called command. And this function is basically where we are going to establish this new command that we have created. We are going to execute it, and then we are going to add it to the undo stack right here. The next one is going to be a public void for undo command. This is going to be called when we click on the undo button in the UI, and this is basically going to cause us to begin reversing our commands in order. We are then going to, of course, have another one for redo command. And this is going to do the opposite, okay? Undo and redo. So up here inside of update, what we are going to do is we are going to check our inputs. So here we have if input.getKeyDown, and we are looking for the up arrow, so keycode dot up arrow. Then what we're going to do is we are going to call the execute command function, and we need to send over a new I command. Now, since move command is of type I command, we can simply create a new one of these, and we can then establish our player movement and movement vector in the constructor here. So here I'm simply going to go new move command, sending over our player movement, and we are then going to send over a vector. Now for this, I'm just going to go vector3 dot up. Okay, and there we go. Now we can go ahead and do the exact same thing for all three different directions. So we have down, left, and right. So I'm just going to go fill those in right now. And there we go. So we have up, down, left, and right. And I've gone ahead and changed those vectors as well. Now, let's go down to the execute command function, which is what we are calling here. So the first thing we want to do is go ahead and execute this command. So we'll go command.execute. Now, for our move command, this is basically going to move our player, okay, based on the given properties here. What we then want to do is add this command to the undo stack, okay, because if we want to eventually undo it, we need to know that it has existed. So here we are going to go undo stack dot push command. Now, push basically means it is adding it to the stack, and you can think of the stack again as sort of like if you're stacking bricks, okay? You have one on the bottom, then one on top of that, then one on top of that, then one on top of that, and push is basically adding one to that stack, okay? Push is kind of a counterintuitive name for something like that, but you get the idea. And basically what we can then do in that stack is we can then retrieve, okay, or pop out a element from that stack, which basically means we're going to get the top one. So you can sort of think we're stacking it up with bricks, and then if we want to start retrieving stuff from that stack, we have to go from the top down. So this is known as last in, first out. Okay, the last thing to be put in is going to be the first thing to be taken out. So what we also then want to do is we want to clear the redo stack, because if we are, for example, maybe undoing and executing commands, the redo stack we basically want to nullify. We want to clear it out each time. So here we're going to go redo stack dot clear. Now let's go ahead and test this out. So I'm going to hop back inside of Unity here, wait for everything to correctly compile. Okay, we have all of our scripts that we have just filled in. And also make sure once again that the command executor has the command executor script. We can then drag in our player into the property here, and on our player, make sure that the player movement script is attached. Now, if I press play, we should be able to move around with the arrow keys. Okay, and if I move around, as you can see, there we go. Now, these commands are being executed each time we click, and it is being added to the undo stack. Now, what we need to do is set it up so that when we click undo, we can see these actions being taken in reverse, and then redo when we want to re-execute them, okay? So, let's go have a look at how that can work. What we're going to do is go down to the undo command function, and in here is where we are going to basically revert back to the previous command. So here we first of all need to make sure that we do actually have stuff in our undo stack. So we'll go if undo stack.count equals 0, then we are simply going to return, okay? Otherwise, we are going to get the current command, so iCommand for the current command equals undo stack.pop. Now pop is basically going to get the top or the most recent command added to that stack. Then what we're going to do is we are going to add it to the redo stack. So here we'll go redo stack.push our current command. So then when we eventually want to redo those actions, we can easily do that by having a look at this redo stack. And then finally, we want to go current command dot undo, okay? Now, down here inside of redo, we basically want to do the opposite. So we're going to check to see, first of all, if the redo stack exists. So if redo stack dot count equals 0, then we want to return and not do anything, because otherwise, you know, we're not going to be pulling anything from anywhere. We then want to get the current command, so iCommand, this is going to be our current command equals redo stack.pop. Then we want to add it to the undo stack, so undo stack.push current command. So once again, we're basically doing the exact opposite thing here. And then of course, current command dot execute, okay? Because since we are redoing those actions, we are moving forward through time again, so we need to execute those. And there we go. That is our command executor script complete. Now, let's hop back inside of Unity and actually look at setting these buttons up. So you can go ahead and create a UI canvas and buttons if you wish, or you can maybe set this up as keyboard inputs. It's really up to you. So I'm going to go to our canvas and I'm going to select our undo button. Then in the inspector at the bottom, I'm going to go to where we have our on click event, and I'm going to add a new listener. I'm going to drag in our command executor and set the function to be command executor undo command. And redo button is basically going to do the exact same thing, but for the redo command function. Okay, there we go. Now, if I press play, you should see that I can move around just as before. So let's say we want to move to the left a little bit. So we'll move to the left here. Now, if I undo that, by clicking on undo, you can see the actions are being undone. I can then redo them, undo them, and so forth. Okay, and then we can move around again, maybe move up here a little bit, down here. We can then undo those actions, and as you can see, we are going back in time. We can then redo them again, and halfway through, I might want to move over here, but if I click redo again, you'll notice that nothing happened, and that is because we are sort of branching off from what we had before. So yeah, that is a look at the command pattern inside of Unity. It basically allows us to store inputs as commands, as objects, and then utilize them however we wish, okay? And once again, this is great for turn-based games where you want to sort of stack a number of commands for the player to execute. This can also be very good in multiplayer games, okay? Because in multiplayer games, you have all these other players sending over inputs. The server then has to determine, okay, this player wants to move here, this one wants to move here. It can be really good for latency issues, okay? If you need to revert a player back to a previous point in time, you can look at their commands and undo them, or if the player needs catching up, you can send over a chunk of commands for them to execute all within one frame. There are many use cases of the command pattern when it comes to game development, and I'm sure in the future when you create more games, you might want to create turn-based games, RTS games, multiplayer games, the command pattern is going to be very useful. Okay, so as a bit of a challenge, what I want you to do is I want you to set up a new command for scaling the player here. So let's just say when we press the S key, that is going to increase the player's scale. Okay, so set up a command for that, set up the input, and I'll be right back to see how you're done. Alright, so I hope you had a go at that challenge. First thing we want to do is create a brand new command. So just like we have a script from move command, we are going to create a new script here. And this one is going to be called scale command, okay? We then want to go ahead and open this up inside of Visual Studio. And the first thing we're going to do is replace mono behavior with iCommand, of course. We're going to remove the start and update functions, and we are going to add in the execute and undo functions right here. Now, before we continue, let's go over to the player movement script and add in a new function for scale. So here we go, public void scale. We'll create a vector3 for the scale amount. And here basically what we're going to do is we're going to go transform dot local scale plus equals scale amount. Okay, and that then is going to add that scale onto our player's scale. Now back in the scale command function, scale command script, what we're going to do is we're going to create two variables. We're going to create a private variable of type player movement so that we can keep track of which object or which player thing that we actually want to modify, and then also another one for a vector for the scale amount. Now we need to create a constructor for this class, so we'll create a public scale command. This is of course going to take in a player movement and a scale amount of type vector3. And then inside of the body of the constructor, we can simply go this dot player movement equals player movement, and this dot scale amount equals scale amount. So basically we're doing the exact same thing as we've done with the move command. Now, down here in execute, we are going to send over, or we're going to call the scale function here that we just created. So here we'll go player movement dot scale, sending over the scale amount. And likewise, for undoing that, we are simply going to negate the scale amount. So here we'll go player movement dot scale negative scale amount. And there we go. Now finally, we need to go over to our command executor script, and this is where we are going to define the input. So here, I'm going to add a new if statement. So if input.get key down, keycode.s for scale, we are going to call the execute command function. But instead of sending over a new move command, we are instead going to send over a new scale command, okay? Adding in our player movement, and for the vector, let's just go new vector3, and we'll go 0.2 and 0.2f for everything here. Okay, there we go. So that should work. That is all we need to do. Everything else is set up automatically for us. So now if we go back to our project and press play, you should see that we can then move around just as before. So you can see I can move around, and now if I press S, we'll increase in scale. I can move, scale, move over here, scale up a bunch more, move around, scale up. And if I undo this, you can see that we are undoing all of those actions, which is great, okay? So you can see how we can add simple new commands in order to really change our game here. And you can add other ones as well, maybe such as a shooting command or maybe a change color command. There are many different commands and things that you can do with this system.